Good morning, pre-algebra. So here is today's joke. Where do you take a sick boat? Well, you take a sick boat to the dock. Oh yeah, that's right, to the dock. Alright, now to math. So I am on page 317. That's where we're starting instruction. Your problems to solve today are 1 through 13 odd. But we're starting out on page 317, so I'll give you a few seconds to turn there. Yes, Andy, I want you to open your book to page 317 and follow along. The pictures in there are much better than mine. Okay, you too, Shelb. Oh, I didn't forget about you, Douglas. I know you. Okay, so here we go. Now, the picture in the book is much prettier than mine, but we're still dealing with similar issues, except we're giving it really real-world application. So in the book, it talks about a Korean War statue, that's this one right here, and a tourist, which is this person right here. So they are casting a shadow. Now think about the sun. The sun is going to be at the same angle for them, so these angles are the same. So I'm going to put a little hash mark. So we know that those angles are all the same. We know that this is a right triangle. So if this is the same angle, these will also be equal to these. Okay? That's what we're getting at. So it's kind of thinking of it like it is a dilation. We're talking about something smaller, but it's a real-world example. So here it is. We are trying to figure out the height of the statue. We know the height of the tourist, 64 inches, and we know the shadow that the tourist casts is 32 inches. All right, and you're looking at the height of the sun is at the same angle, so the shadow that the statue, you can actually measure that at 43.5 inches, but you're not allowed to actually climb up the statue and measure the statue. You would probably get arrested and beat up. Probably not beat up, but someone would yell at you to get down at least. So we gotta do some math to find the answer. So here's what we need to do is that we're doing our normal comparisons we're talking about the height with one and then also the shadow length with the other. So we have to make our similar fraction that you have seen all week long. So here we go. Our book starts out by saying that we're going to start out with the tourist height. It really doesn't matter which one you put on top or on the bottom. You just have to be consistent. So they're starting out with the height, and I would suggest that you start out with your height always, and then do your length. All right. So the height of the statue is that we're going to put that. The tourist. You're doing the tourist first. My bad. So our tourist height, we know that of 64. Okay. Do we know the statue? No. So this column is your height. Now this column is going to be your length. So what matches with the tourist? Well, we have to go across. We want to match our tourist. And the length of the tourist's shadow is 32. And we know that the length of the shadow of the statue is 43.5. So that's how we set it up. Remember, when you're talking about our angles, they stay the same across. But your similar sides are up and down. That's why we have these columns. Okay, so now we can solve this. So we end up getting 32h equals, and 64 times 43.5 is 2,784. All right, and then we divide 32 by both sides, so that our height of our Korean soldier statue is 87. 87 what, good students? That's right, 87 inches. Okay, that is our answer. So again, the thing that is probably confusing is, hold up, Mr. T, how did you know to set up these numbers here? Well, again, we want to start out, just pick something. So you could pick the tourist, you could pick the statue. And like I said, start with the height. So we started with the tourist, that's what they want, so they put the height here. So in the column, the fraction should always be dealing with height. So we know the height of the tourist, but we do not know the height of the statue. So that's our unknown. Let's make that a better h. Okay. Then we did our other fraction, which is the length. We know the length of the shadow of the tourist. Remember, they have to match up. It's important. And then we know the length of the shadow of the statue. So that's what we can measure. So that's how we know what to set it up. So let's do the example problem right below. All right, looking below, it says, suppose a bell tower casts a 27.6-foot shadow. At the same time, a nearby tourist casts a 1.5-foot shadow. If the tourist is 6 feet tall, how tall is the tower? So I'm just going to make some quick triangles to help me visualize. So there's our tower, and there's our tourist. Like I said, you may need to write it to help you visualize it. So we're talking about the tower casts a 27.6-foot shadow. So our shadow is going to be the bottom. Remember, if we're thinking that this is the tower, then if the sun is up here, obviously the shadow is going to be cast that way. Now our tourist, we'll give him some little arms, his shadow is 1.2. Ooh, I forgot my feet. Alright, and what do we know the height of? Well, we know the height of the tourist, and he is 6 feet tall. 6 feet. So we need to find tower feet. Okay, so let's pick our tourist. Just like from last time, let's pick our tourist, and we're going to start with our height. So our tourist height is 6 feet, and our tower height is unknown. It is t. So now we have to stay consistent. Our tourist shadow is 1.2, and our tower shadow is 27.6. Alright, so we have 1.2 t equals, do the calculator, 27.6 times 6. Oh, I think I did the wrong number. 27.6 times 6 equals 165.6 divided by 1.2, and t equals 138 what? Feet. There it is. So that's how tall the tower is. 138, and I am correct. Okay, so there's that practice problem. Now turn the page. One more practice to go through with you. So now we're talking about surveying. So surveying means, scoping out a piece of land to build on. So this is something, the land that the new house is being built on had to be surveyed. It had to be we had to make sure that it was usable to build a house on. So let's go through this practice problem together. So it says in the figure, triangle STU is equivalent, that's what the little squiggly means, is equivalent to VQU. So we have STU is equivalent to, what is it, VQU? VQU. Okay, so we know we have same angles. Find the distance across the pond. So we can use what we know. We have to deal with similar angles. So we have a triangle like this, and then we also have a triangle a little bit smaller. We're dealing with our same angle like this. Okay? And the angles that we know, the sides that we know, we're trying to find across the pond. So we have to say x meters. So we're dealing with meters. And what we know is that this is 20 meters. And the only other information is 10 meters and 16. Okay, so you're probably thinking, hold up, how are these similar? Well, we need to find similar sides. So what will help with that is figure out which is the angles. So which side has would compare to our 20? Well, our 20 would go with our x. You see how it has to go with the right angle down to the corner. So 20 and x are the same side. And then 10, we would know that 10 and 16 go together. So like I said, start with your height first. So we know the height of the small little piece of land that's not with the pond. So we're going to write 10. Now, do we know the height of the pond that we're trying to figure out? Yes, that would be 16. Okay, now let's look at our length. What does 10 go with? Our 10 goes with our 20, and then our 16 goes with our x. Okay, now let's whip up some math. We have 10x equals 16 times 20. Is 320. And then divide both sides by 10. And x equals 32. Whoa, not 30. Sorry, I'm just not thinking fast enough. 32 what? Meters. Good. And is that the same answer as in the book? It is. Okay? So again, just like it is for me, it may be helpful for you to draw. I know it takes more space in your book, but visualizing it helps me, and it could help you. Again, if you need any help with these problems, let me know. I'm more than willing to help. Go ahead and work hard. Remember, you're working on 1 through 13 odd. And as always, work hard, and I will see you in real life.